So we now have seen how a voltage and a current flow can be induced in the secondary. The induced voltage depends on the strength of the magnetic field and the number of turns on the secondary coil. More turns on the secondary will generate a larger voltage. The strength of the magnetic field, though, depends upon the number of turns on the primary. So the voltage output of a transformer depends on the relationship between the number of turns on the primary and the number of turns on the secondary. So let's now have a look at that relationship. This is the transformer formula, and it's one that you need to know. It simply tells us that if we take the ratio of the voltages, secondary divided by primary, it's the same as the ratio of the turns, secondary divided by primary. Easiest way is to go through some examples. If we take 10 turns on the primary and 10 turns on the secondary, we look at the ratio, secondary divided by primary, and it's 1. 10 divided by 10 is 1. If we put that into our formula, and then rearrange the formula, what we know is that the output voltage on the secondary is 1 times the voltage on the primary, or that actually both voltages are equal. So equal number of turns, equal voltages. 240 volts in would give us 240 volts out. 10 volts in would give us 10 volts out. If we look at a different example where we have 10 turns and 5 turns, we now have less turns on the secondary. If we take the ratio of that, 5 divided by 10 is 0.5. We put that into our formula, rearrange it, and this tells us that the voltage on the secondary, the output, is half of the voltage on the primary. In other words, the voltage has stepped down. It's a step down transformer. We have half the turns on the secondary, so we have half the voltage on the secondary. You can probably guess what happens when it's the other way around. Again, work out the ratio, put it in our formula, rearrange the formula, and this now tells us that when we have twice as many turns on the secondary, we get twice the voltage on the secondary. This is called a step-up transformer. So in summary, voltage causes electrons to flow. Flow of electrons is a current. The current generates a magnetic field. By looping the wire, we can increase the strength of the magnetic field. The magnetic field passes easily through iron, and changing magnetic field induces a current in a conductor. Therefore, transformers have to use alternating currents. They will not work if you just connect them to a battery. The output voltage is equal to the ratio of the number of turns multiplied by the input voltage, or in other words, the ratio of the primary and secondary voltages is the same as the ratio of the primary and secondary coils.